Okay, so let's define some stuff. Okay, so without loss of generality, yeah. If you don't know what that means, ask. We'll let C1 be a circle with maximal radius. Does that make sense? So it's the biggest circle. Yeah. Okay, without loss of generality.
Generality is like general.
Like because the condition is cyclic, right? Like we started drawing C1, C2, C3, but we could have just started drawing like C3, C4. We could start anywhere, right? So let's start with C1 being the circle with the biggest radius. Yeah. So without loss of generality always happens when generality actually is lost. Okay. So you're kind of trying to prove something. You're trying to prove something in this generality, right? Like for all numbers, or for all circles, or for all circles satisfying this condition, right? But then for some reason, now I'm proving it for all circles satisfying this condition, with C1 being the largest circle, right? So now I have an extra condition, right? Which makes it look like generality has been lost because I'm proving it for less things now, right? But actually, I'm proving it for the same number of things. And when I say we're log, is I'm trying to say that. Yeah, it can be abused a lot. So some people say we're log and actually lose generality, and then yeah, it's a very yeah. It's kind of like it's an upper class move. Like in chess, it's like you resign to show respect or something. Like. Okay. So this is what solves the problem, Rihanna. So you let this so this is actually Leo's idea. So solve the problem with the C1. Okay. If you let C1 be the biggest radius, C1 can only contain other things that can't be contained in anything else. So you'll see how that solves that issue. Okay. Okay. Now we define some other things. Okay. So we're considering. So we define the level. So define LK to be the level of CK. Okay. And what does that mean? Okay. So CK is the kth circle, right?
Wait, you don't know.
What? Don't interrupt with a question for Leon. You ask me a question. Okay, so the condition for the level, yeah. So we say LK is a level 0, yeah, yeah. If it's not inside C1, okay. And our notation for whether something's inside something else is like this. So this is if it's inside C1, okay. And usually in maths, if it's the not of that condition, like the negation, you just put a line through it. Yes, that does not need to be asked. It's automatic permission all the time, okay?
We can just sit on anything. So can we just sit on anything?
Yes. Well, except for like
people,
things that will break.
people, except for people. We can't do people.
Actually, you know the last beanbag, how it broke? Was someone sat on the beanbag at the same time someone else.
What?
So it was like someone was playing with their laptop and someone sat on the beanbag and the beanbag cut itself on the laptop and just opened.
It wasn't the black one.
Yeah. It was like two people basically sat down at the same time. One person's beanbag cut itself on the laptop.
And then what happened?
And then we lost the beanbag. We lost 200 liters worth of beans.
No, not the beans.
How much did it cost? Like 20.
I see the beanbag is winning the competition for the attention over this very nice proof. we love beanbags.
I'm gonna sit on your bed.
Okay. Does that make sense?
Yeah.
So 0 if it's not in C1, right? And otherwise, it's like the biggest chain. So the length of the biggest chain. So otherwise, CK is in C1, okay, and LK is going to be a positive integer, yeah, equal to the longest chain, the length of the longest chain, yeah.
Oh wait, there's two.
Yeah.
Length of the longest chain, CK, C, it could be like K1, K2.
CK2. Oh my god. Oh, yeah.
So length all the way up to CK
16.
L. Oh, this is an abusive notation right here.
Take a staircase.
Length L. Does it make sense? So if it's inside C1 and there's nothing in between it, then it's just equal to 1, yeah? So it's just how many times it goes nested, yeah? So LK is the number of times it's nested, yeah? Okay. So this is the same. I think you'll get more out of school. Actually, I just realized you only do like about 3 hours of maths at school a week.
You?
Yeah.
Our maths teacher doesn't teach us maths. He just gives us
One
physics.
week we do 4, the next week we do 2.
Yeah, I get
Really?
4 periods on 8 weeks.
Is a period an hour?
Yeah.
Leon, Leon.
Osu?
Osu?
Oh. So
Wait,
if
Osu? I have found proof. Here.
Leon.
This is what we're trying to prove.
Leon,
2 sigma notation. I don't know
Ah,
what any
yes.
of those words mean.
Very understandable.
Oh no.
Okay, so listen to me, okay? Every time I teach you something, I never teach you the thing one off. You understand? I'm always teaching you a way to do it. Does that make sense?
Yeah.
So when I tell, like,
Chat's
I'm not gonna tell you how to write a proof of this, and then I'm not gonna tell you how to write a proof of that, and then tell you how to write a proof of this, and hope eventually you learn how to write a proof. Yeah. I teach you how to write a proof in one go, and I'll never tell you again. Hopefully, but I'll probably repeat it a lot. Okay. So
Chat's red.
don't accept the imperfections. Okay, do you understand what LK is defined as? Huh? So LK is the level of so LK is the level of the kth circle. Yeah.
Okay, is the biggest.
So if this is C1, right? And there's like a bunch of circles, right? And CK is here, yeah? Right?
That's the big one.
You see the level is 2, yeah? So if there's 3 circles, the level is 2.
Oh, are you similar?
Make sense? Yeah. Yeah. So maybe we also have like L1 equals 0, yeah?
What is CK plus 1 is like outside. Then it's a level? The level plus 1 is
Like-
in our circle.
What do you mean, like here?
Yeah, is the level of CK still 2?
The level of CK doesn't depend on like where this circle is.
It depends on how many circles there are.
Funny thing, that circle doesn't even
Yeah. So it's how deep it goes inside C1. That's what the level of a circle is. Okay. It doesn't depend on what other circles are. And see, if this was the K plus first circle, what's the level of it?
0.
It's 0. Yeah, it's outside of C1. Yeah. Okay. So we're imagining we're putting everything in sequence. Yeah. So we're doing C1, C2, C3. Yeah. So now define PK. Yeah. To be the points lost by this kth circle. Okay. Does that make sense? So this kind of thing sounds very clear, but you might want to expand on it a little bit. So it's not the points lost by the kth circle with all the circles. It's just the ones before that. Yeah. So it's the total points CK doesn't score with C1 all the way up to CK minus 1. Yeah? Okay, so it doesn't count for the next one. Okay? So if CK doesn't go with CK plus 1, then that counts for PK plus 1, not for PK. Yeah? That makes sense? So the PK only counts for the circles that have a lower index than the one that you're at. Okay? Okay. Are these definitions clear?
Yeah.
Okay, now I want to make the following claims. Okay? So what are the claims I want to make? Claim, so I should also use claims. Another word for claim is like lemma. Okay?
Isn't CK like the smallest one?
Huh?
No, CK is the biggest one.
The smallest one. It's the innermost one.
Yeah, the innermost one.
Smallest one. No. Yeah, it is.
So doesn't school with these means like this isn't
Well,
Yeah.
well, the small circle
so
should
that's
always
just
score 0.
that's just K plus 1. I'm missing one.
No, it's not necessarily the smallest one.
Okay.
So for example, look at well we'll see when you do the small case, okay? Okay, the lemma. Wait, we're missing someone.
Rihanna.
Rihanna's diving at
She went to the salon.
the secret high.
You mean the salon?
Okay, so lemma P EJ, yeah, plus LJ minus LJ minus 1 is greater than or equal to 1 for J between 2, so for J bigger than or equal to 2, less than or equal to n minus 1. Okay? So I'm trying to state these things a bit more rigorously than I usually do. So one thing that you'll notice is that the variables are quantified. Okay? So I don't just leave a J in there unless I tell you what the J ranges from. Okay? That's kind of important. So I'm going to write some lemmas and you're going to try to understand what they mean and then we're going to prove them, okay? And I might use the word proposition just to give you an exposure to the lingo. So sum of P.
Hey, look, I used sums too.
I oh, what? Oh, yes. Yeah, so we're trying to improve the layout of this room. So possibly moving the whiteboards somewhere over here and putting couch over there and maybe possibly...
But then what about the charging?
Yeah, that's my beanbag.
No.
It's
Ow.
ours.
Two idiots fighting over a beanbag.
Leon,
You're one.
you were literally just saying, hey, it's mine.
I'm just saying.
I don't handle Right, I'm with Charlie.
I don't know what a grade is. What are those doodles of right now? 10 seconds till midnight. What? Warning clock, 10 seconds till midnight.
What?
Kidding.
It's, oh my god, it's so hard. Oh my god.
What? So hard, no.
It totally says pot.
P-I, right?
Alright, lemma 1, yeah?
P-I.
Proposition 1.
Lemma or lemma 1.
Lemma 2.
Proposition 2. Lemma 2.
So L's the level, right?
Yeah.
That was the level.
See, I think one thing that'll be really tough for young people to formalize proofs is, I mean, this is not necessarily a bad thing. I mean, you guys are trying to understand things, just get the idea of it, right? Whereas the proof, it demands more than that. It kind of demands every little detail, right? So even though you can't get it, I would recommend not giving up on knowing the idea of it, because that's very important, okay? The detail thing is not as important. It's just something that you'll eventually grow into. How about that? Yeah. So be patient if this doesn't make sense. Yes, that's the spirit.
Well done, well played.
Okay, so lemma 2, we have P.
Oh no. Okay. Okay. Okay.
What's P again?
He is
He's
the point slot, right?
Oh, the point source.
On what state?
Huh?
What state?
A1, A2.
No, it's just a random. It's like
A number.
like thing. It's basically group of this, like group of consecutive sections. It's this drag. Basically, like this. It's like A1, A1, and then this would be like the second group like of consecutive.
You're gonna break me on the first. What if it's 0?
What do you mean?
Oh,
It's zero?
Yeah,
If it's 0, then
Did
it's
you just
one.
Rusu sucks. I hate you for that.
If it's 0 local, right, then AI minus 2
The
is
first time I
0.
played this, we got S rank.
No, you did not.
I
You
got A
never
rank.
got. Yeah, you got A.
No,
That was not the first time.
I was like,
What's that? I don't know, man.
What?
then the first time we went to this.
Okay, so the nice thing about kind of proofs,
Dion,
so the nice thing about proofs, it kind of focuses you on the exact statement. Yeah. So in 4 statements, I claim we solved the problem. Okay.
Wow.
Wow.
So it's kind of nice, right? Like if you think about the problem intuitively, it's kind of all over the place, right? But this kind of cleans it up and makes it very neat. Okay. So let's try to understand these lemmas and let's try to prove them. Okay. So this is actually probably a corollary. This is also. I'll explain as we go. Okay.
Corollary.
Maybe I'll state a corollary after that. So corollary. The the maximum score is at most n minus 1. Choose 2. Yeah. Okay. So look how nice that looks, right? You would you expect the argument to be this clean?
Oh my god.
And then from the corollary, you just find a case where the minus 1 is not.
Yeah. So a lot of it depends on the definition. Okay, because you need the definition to be able to prove something, right? So it's a battle between a nice definition versus a useful definition. Okay, so when you define something, okay, you always have 2 choices. You have the choice it's like the nice definition is kind of like the one that everyone agrees on and it's definitely the right thing, right? So it's like it's how people start if they didn't know anything. Okay, so that's nice, but it might not be very useful. Okay, because you don't know what obstacles you're going to come against. Okay, so you don't focus on the properties that will overcome those obstacles. And so if you took a bit more time to define it, you might have less trouble overcoming the obstacles. Okay, And so as with everything, it's sort of like you out of all the things you have, if you're in control of it, you're trying to even out the difficulty as much as possible. Yeah. You don't want really like some super difficult thing in between and everything else is easy. Yeah. You want everything to be roughly the equal difficulty. Okay, so let's see if we've actually achieved this or not. Okay, so the goal by the end of this is to convince you this is correct. Okay. And this is the kind of huh? Yeah, I mean that's good. I think that's a good thing, and people should be harder to convince when you're in the classroom. It's just sometimes unproductive because your teacher can't do it any better.
Definition of points lost.
Yeah, so the definition, see, yeah, good.
Points lost is like the amount of circles that doesn't score points with it, right?
Yeah, so like the points lost for J, you look at the Jth circle and you pair it with all the indices less than J, and however many don't score is how many points are lost. Okay, so let's prove. Maybe lemma 2 should be lemma 1. This is the easiest to prove.
Yeah, it is.
Gonna prove lemma 2. Proof of lemma 2. Alright guys, so the thing I've been telling the people all the time, like if you're mucking around, you better be really good, okay? Because if you're bad and you're mucking around, that really annoys me. Okay, so proof of lemma 2.
So ln minus
Yeah.
Well, the maximum points.
So remember, n is a number of circles, right?
Is L like the distinctive?
Huh?
L is level.
L is a level.
If we look at the minimum number,
N minus
like the minimum
the
like
nesting level, so
PNs, we
like
get
how many?
Yeah, so like let's look at. So consider
the smallest PN can be.
Cn minus 1, yeah? So basically the level. So it's kind of like Randall was saying, there's kind of a few cases, right? So consider Cn minus 1. It can either be, it could be not contained in C1, right?
Yeah.
And in which case the level is 0, yeah?
It could
Right.
be contained in C1 but not in C2.
Yeah.
Okay, it's a 0, 1.
Yeah.
Generic.
Okay, otherwise Cn minus 1 is contained in C1 and Ln minus 1 is greater than 0.
Wow, it's so obvious.
I know.
It's actually obvious.
Yeah, I guess that's kind of the goal, is to make it really obvious. So when Ln minus 1 is 0, okay. See, how many points can you lose?
But then we have to prove that PN can't be 0.
PN always has to be greater than equal to 1.
Otherwise, it's not.
Is PN always strictly bigger than Ln minus 1?
So how do we make sure Pn always loses a point if Ln is 0?
Well, we could find like the smallest case of PN that could possibly be.
Since Cn minus 1 isn't in C1, then the P of n minus 1 is
Maybe this is... Okay, so we have a C1, right? And then the Cn minus 1, for example, where could it be, right? It could be like this, yeah? Yeah? Oh, by the way, did you know it's an open problem to count the number of ways circles can be positioned relative to each other?
How much?
Yeah.
Isn't it infinite?
Oh no, like you don't count like minuscule adjustments. It's like
Contained.
for example, 2 circles, yeah? You only count it. These are the only configuration for 2 circles. So like if you have a circle, the inside.
Outside, inside,
Yeah.
both.
Oh yeah, outside. I won't draw it. Yeah, well it's like outside, yeah. And you don't count the tangent ones, but like here there's like 3, right? That's an unsolved problem for n circles. Anyway, so this is not the case when Ln equals 0, yeah. Ln minus Or it could be like this, C1, and it's like outside here. Yeah. Okay, so here's the crazy thing, right? So how do we place the circle CN, right? Okay. So it has to go through the center of this circle, yeah? Yeah. I guess there's another case where the center is like inside, so it could be like this. And the center's here, right? Yeah.
Smallest P n can ever be is 0. Therefore, the left wall would be n minus 1 plus 1.
Oh my god. Bruh.
Okay, so the problem is, so here, if you don't want to lose any points, right? You have to go inside like this, right? Yeah. Here, if you don't want to lose any points, you have to go outside like this, yeah?
Indeed.
And here, if you don't want to lose any points, you have to go outside like this, right?
Can you go inside as well?
Then you'll lose points.
Here. Oh, okay, so here's the fundamental problem, yeah? So Cn, the center of Cn has to lie on C1, right? Yeah? So if the center of a circle lies on another circle, then the some part of the circle is outside of C1, yeah? So there's always a direction that's outside, right? And in that direction, Cn will be outside. That makes sense? So basically, it comes down to this, okay? Cn, for it not to lose any points, it has to not lose any points with C1, right?
Yeah.
Okay.
Wouldn't points loss be 0? Points loss.
Huh? No, it has to. So the point is, look, Cn is already outside C1, okay?
Yeah.
So the only way to not lose points is to encompass C1, right? Because if it can't go inside C1 because it's already outside C1, right? If it encompasses C1, C1 can't have the biggest radius, right? So it can't encompass C1. It has to lose a point with C1, okay?
So that's the minus.
Yes.
Control.
So here we lose 1 point with C1, right? So Pn is greater than or equal to 1, yeah? And that's what we needed to prove for that, right? See, if this is 0,
It can only be 0. The smallest it can.
then it needs to be greater than or equal to 1, yeah? Okay. Now, if it's not 0, it's even easier. See, so you consider if Ln minus 1 equals L, right? Greater than 0, yeah? So that means there's a sequence. So CK1, CK2, CKL, yeah? In here, yeah? There's a nested sequence. There's L plus 1 circles, yeah? Okay. But we know, so this last one here is actually Cn minus 1. And the first one is C1, right? Okay, I should probably, did I write that before? Yeah, K, yeah? See?
Can I eat my coffee?
Okay, so remember the point was the nth circle, right? Has to go through the center of the n minus first circle. So it's got something inside it. Yeah? And since the so the nth circle, so Cn is inside Cn minus 1. So partly inside, possibly. Okay, it's either completely inside or partly inside, right? But Cn minus 1 is inside all of these circles, right? Yeah. So which is actually inside of all of these circles. Yeah. Yeah. Okay. But also Cn, the center of Cn lies on C1, right? So sum of Cn is outside of C1.
On the inside scores no points, right?
So then looks like M-1.
Yeah.
Okay, it could be partly or completely outside, yeah? Okay. But C1 contains all these circles, right?
Yeah.
So now we know it has to be partly inside and partly outside, right? Because if it can't be completely inside and completely outside, that's a contradiction, right? So if it's partly inside all of them and partly outside all of them, it means it doesn't score any points with them, right?
Yeah.
So they lose
So
N
partly
minus
doesn't-
1 points.
So partly doesn't-
So it loses. It loses however many circles there are in this line, right? And there's L plus 1 circles, yeah. So it loses Ln minus 1 plus 1 points, yeah. That makes sense. Yes.
Yeah.
Feel like you're not quite getting it.
Yes.
So complicated.
I am
Yeah.
anxious in the time they will come soon.
So basically, you have all these circles nested together. Let me draw a picture for you, okay?
So many C's.
Yeah. So notation is not that important, but I'm not gonna like baby you and protect you from notation, yeah. Because it's probably the easiest thing to learn. Actually, most subjects other than maths, all you learn is the notation, and then you don't actually do anything. You get a test on the notation.
Learning grammar in English, but not learning.
See, look, this is how it works. If you have all these circles, right? The last circle has to be in the middle, and it has to come out of the outside one, right? That's exactly what we did for the final thing.
C's just on the inside, but it's more C's.
C is the surface.
So therefore,
Small C's. Big C's.
C. So therefore, P n is greater than or equal to Ln minus 1 plus 1. Yeah? Okay. That's good. So we proved this lemma, okay? Lemma 2 is proved, yes? Okay.
Oh, yeah.
Oh, that's
I see this is not in the garden.
Okay, let's try to prove lemma 1, okay?
PJ, It's good if we had some inequality about between LJ and PJ.
Okay, have people heard of mathematical induction?
Yes.
Yeah.
So the mathematical induction works like this.
Use base case.
So if you want to prove a statement that so here we have a statement for j, right? We have a statement for varying j, and j is a whole number, yeah. So what we do, if we want to prove it by induction, what we do is we prove it for the lowest value of j, okay, and then we prove that anytime it's true for any j, it's true for the next j. You're not listening. I'm not going to repeat. Yeah.
We also need to prove the base case.
I only sort of service and like repeat and sort of care about stuff when people actually try to make the most of the opportunity, yeah? So if I'm saying something and you have like no regard for it, I'm not even repeating it. You're just missing it, you know what I'm saying? Okay, so basically you have to prove, for induction to work, you prove it for the lowest case, and then you prove that anytime it's true, the next one's true. Okay? So you prove it generally preserves the counting, yeah? So that way if you want it to be true for anything like further on, then it's true for the first one, and you just keep pushing it forward until you get to the one that you're up to. Okay, so let me show you how this works. Oh, Leon explained this to you.
Nice.
No, I'm actually very happy that Leon did that. Yes. So let's try to carry out an induction. So induction is in your high school like extension 1 or 2 syllabus, okay?
Wait, what? Wait,
Oh,
Wait, what?
Are you sure? We're in Bruce.
It's like mandatory in term 1.
Oh, do you already learn it?
Well,
I thought it was in like
we learned set theory in school just today. Today's the first day we learned set theory.
And last week
Yeah.
we used sigma notation to solve for pentagonal numbers. That was nice.
Okay, so this is called the base case. Okay, base case is the lowest value for which you want to prove it. So in this case, it's j equals 2. Okay. I mean, you could probably do it for j equals 1, but it's not very interesting. I think we know what j equals 1 is all about. Okay, so for j equals 2, what happens? You're trying to prove that p2, right, plus l2 minus l1, yeah, equals, or is greater than or equal to 1, right? Okay, this is really easy, right? Because, so this is C1, right? So what's L1? We just defined L1 to be 0, right? So this is literally P2. We need to show that P2 plus L2 is greater than or equal to 1, okay? Okay, so we need 2 circles, yeah? So the second circle basically can do, it could stay inside it, right?
Or outside.
Or it could not go outside. It could, yes, don't touch the TV.
It could go in the middle. So
Okay, so if it goes inside, right? What's P2?
Point loss is 0, right?
You don't lose any points, right?
So L2 is bigger than L2.
And what's L2?
L2 is bigger
L2
than
is
L2.
1.
Is 1, right? So the sum is true, yeah? What are the other case? So it could go outside like that, right?
Point loss is 1, which automatically proves
Loss
it.
is 1 and L
Is 1
Also proves
and L2 is 0, yeah? That makes sense? Because L2 is just the level of how nested it is, right? And it's not nested at all. And P2 is 1, right? Because it lost 1 point from not being nested, yeah? So it's true, yeah? So we proved the base case, okay? So now we want to prove...
Is J like... Okay.
Actually, I'm not even sure we even need to do this by induction. I think it might just be true.
proving that
True by
Okay, we saved the induction for something else, but it's nice to look at the small case to understand how this works anyway. Okay. So now let's consider. So actually, this would only be interesting if j greater than 2 was somehow different than the other case, but it actually probably isn't different. Okay. So what do you have, right?
you have.
So you basically have like C1, right? You have a bunch of things. So for example, that's Cj minus 1, yeah? Okay. And you want to know what Cj does, okay?
No, J is variable.
So for example, Cj could come out, it could come out all the way, yeah? Right? Or it could kind of just come out a little bit. You see? Okay. So what Lj minus 1 is really just a change in level, yeah? That we can even call it Lj. Change.
Isn't it just oneness?
LJ is equal to J minus.
Huh?
It's just J, right? The level. If they're all nested. Perfect.
Say again.
Is PJ plus LJ is equal
Pj plus Lj.
For base case, J equals 2.
because if it's not inside C1 and then it's outside and it was if it is then since J minus 1 is always square root 1.
What?
You're saying Lj plus Pj is equals L. I don't think that can be true because you can just not gain any points at all, you know?
Yeah, excess. You just have a bracelet.
If you lose all the points.
If you lose all the points, then PJ equals J minus 1. And then
Oh.
LJ equals 0.
Maybe that's... So you're saying it's actually equality holds.
Well, that's very bold.
Whoa, are you saying that Are you saying PJ? You're saying PJ plus LJ equals LJ minus 1 minus 1? Is that what you're saying?
If you plus LJ on both sides. What are you trying to prove? What is your argument?
Wait, what is your statement? You're saying PJ plus PJ is great plus LJ
I thought I was equal to J minus 1. J minus 1.
equals J minus 1.
Yeah, but in the previous one, we did LJ minus 1 plus instead of J minus 1.
We could try with 3. Let's see if it works with 3.
Okay, for 3, yeah?
So what would
For 3, there's the inside case, and then it could be inside the big circle. That's
So that's 0, yeah? P is 0, L is 2. So that works, yeah? Inside, and then it could just come out like that, right? Then the point loss is 1, and the level is 1.
We could have the middle case.
Oh, I think I kind of. What about this? Actually, I think I have a case. So what if this happens, right? Yeah, I think I understand. So if this happens, right, you can actually get inside. So if something like this happens, so if something like that happens, you have like overlapping circles, right? You can have a circle, like, because the level will only increase if you put it inside C1. It doesn't care if it's inside the other one or not, right? So you have two different values of P for the same level. You see? So if I put it here, yeah, then the points lost is 0, yeah? But the L is 1, yeah?
The point loss 1? Wait, between the two circles, 1.
No, because the point loss only counts about this circle.
instead of J minus 1, is it equal to LJ minus 1?
LJ minus 1 plus 1 instead, just LJ.
Oh, okay.
The LJ equals LJ plus.
LJ minus 1 plus 1.
Actually, it could be, yeah. Let's look at this proof, yeah? So let's see where we use the inequality. If we don't use it, then you're right. Okay, so actually this lemma is not by mathematical induction. We save the induction for later, okay?
Can we use induction twice?
So what? So we're trying to show that Pj plus delta Lj is greater than or equal to 1, yeah?
Points lost is 0.
Points lost is 0.
The LJ is 3.
LJ
3.
Second count. And that one.
But then it contains one extra circle. The big circle.
Yeah, I guess the problem is, see, like, if you look at if you look at Cj minus 1, right? Yeah? If you look at Cj minus 1, yeah? Right? It's going to have Lj minus 1 circles, yeah? So it's going to be contained in all these circles. And then there's Lj minus 1 plus 1 circles here, right? That makes sense? So you're guaranteed to have that. And you're guaranteed that, so let's call the center, this is the center, yeah? That thing there, right? Cj has to pass through that, yeah? Let's call the center like Oj minus 1, okay? It has to contain the center of that, right? So we know that, and it has to get, so if it changes level, right? it has to break part of that chain, yeah? So I guess the thing I'm trying to tell you is that all we know is that it breaks some of that chain, yeah? We don't know what other stuff it breaks. Like it could be in like a bunch of weird chains, you know, like you know what I mean? So that's what the inequality is for. So it could break some chains like that you didn't even anticipate. Like there could be some chains that were just created for no reason that were broken as well. You know what I mean? So it's basically like there could be collateral damage to you coming out of the circle. That makes sense? So like so if you look at this picture, the red circles, right? Like the inner so I've taken into account that the purple circle comes out of the innermost red one and comes into this part, right? But there could also be a bunch of other circles, for example, in light blue, right? For which, like, you know, it could have lost points with that circle for no reason, right?
Then doesn't that break the tree?
No, it doesn't, because the blue circle could have come from before. It could be like 100 million circles. You understand? And part of them is like a sequence of red circles nested. Yeah. And then the blue circles could go crazy in another chain, right? And then it could come loop back around and just be a collateral damage to this purple circle. You know what I'm saying? Yeah, like I mean, look, like imagine there's a blue circle, yeah. If the blue circle was here, there'd be one less point lost, right? But if the blue circle moved to here, there'd be one more point lost. You see? So it's unlikely to be equals. Yeah, I'm actually sure it's not equals now. So okay, so you have a chain like this, right? So CJ, so I mean the easiest thing is if the level increases, right? If the level increases, so level increases means LJ equals 1, right? The level can only increase by 1 at a time, right? Well, PJ is always positive, so then you don't have to show anything, right?
Mhm.
Yes?
That's a triangle and not an angle, right?
Yeah, it is delta,
Delta.
capital delta. So it means it usually is a change in physics. It's used for change in. I don't know if you've seen derivatives.
Limits.
Derivative is like
Yeah.
delta
X.
f on delta x. It's like that's what a derivative change in f over change in f. Whatever.
Plus C.
That's not.
Optiven logo is also delta,
Plus
but
C.
we won't talk about plus C. No, you don't plus C when you do it.
Okay, so if delta if you're increasing in the length, then you're fine, right? There's nothing to prove, okay? It's only when you're not increasing that's a problem, okay? So for example, what if delta j lj is equal to 0? Yeah? So what happens is you have c j minus 1 is like that, and cj is like this, yeah? So you've already lost the point, right?
Yeah.
So it's already greater than 1, yeah? So it's only when it's decreasing that's a problem, yeah? And how do you decrease? Well, you need to break some of this chain, right? So maybe the chain breaks. So now see like this.
Go outside.
Like not
So
completely inside.
so the purple thing breaks the chain. So the purple thing could have gone inside the red one, right?
It's not completely
What
inside.
happens if it?
Blue one also
Only
breaks
partially inside.
What happens if it breaks
No, the
chain
blue
and
one is
goes
not the
back
current.
again?
The blue one,
The blue one?
only the purple one has power to do anything. We're only considering the purple one. Huh? The blue one's already
Is
put.
it a consecutive chain?
It doesn't have to be consecutive.
nested
I didn't say
Like
consecutive.
a nested chain.
But that's a good question. I never said consecutive, yeah? So it could do this. It could like. So the chain could start like this, yeah? It goes in, right? In, and then this one like goes out, right? But then it could start again in here, see?
Wait,
So it doesn't.
doesn't it
break
have
the
to?
It doesn't have to be
like
consecutive.
the same chain?
Wait, so that one doesn't break the chain?
Which one?
The
The whole
one
of the
that
blue.
went out doesn't break the chain?
All aqua.
Does what break the chain?
The one that went out.
So the one that went out, at that stage, it broke the chain, right? but the next one could still continue the chain.
Wait, but then what is the which circle is the next one? Is touching the center of? Which circle is the next one touching the center of?
Which circle is the next one touching the center?
It's like the little one.
Yeah, so let me just draw the colors. You can see the order of that pretty clearly, right? Then the next circle is here.
Yeah, but then so wait is it touching the circle over there? Circle?
Kind of forget about the condition for the moment. Yeah, it's the condition of it. Like, I mean, yeah. I mean, the condition is sort of enough for us to play this game, but we don't have to play it that precisely all the time, yeah? Okay, so does that make sense? So this chain has like, it starts with this one, and then it goes this one, this one, this one, this one, yeah? So it has level 5.
I saw it, yes.
That makes sense. It has level 5. Yeah. I guess the point of that is like, and actually it has to have level, like, it's kind of crazy because for the thing not to lose points, it has to literally gain points with everything, you know what I mean? So it's not just nesting in the next one, it's actually nesting in everything it can. And the things that it can't nest in, it has to envelop. So it's actually a super hard condition to maintain. So actually the easiest way to do it is just to keep nesting, you know? But if you start breaking the nest, it's actually really tricky because you have to lose lots of points. Okay, so
Unless there's like some overlap.
yeah. Okay, so
Well, that's a set.
Figure it a set.
Are you thinking of that? Well, asking. I was thinking if infinity was a natural number and if it wasn't, then what's the largest number?
okay, so listen up. So the chain has to get smaller, right? So basically, first of all, Cj minus 1 cannot contain Cj, right? It can't happen, right? And then you have a smaller chain involving C1, you know? So, for example,
Someone coming.
Just a prediction.
Let me do this. So you could have Cj minus 1. Okay, this notation is getting a bit out of hand, but like, if you look at this diagram, right? The red circles represent the first chain with the Cj minus 1, yeah? And the purple circle represents Cj, yeah? So Cj has decreased 2 levels, yeah? So it's decreased 2 levels. But to decrease 2 levels, it has to actually escape 3 circles, right? Yeah? So it loses 2 points, yeah? So decreasing 3 levels, so change is -3. Sorry, change is -2. Points lost is 3, yeah? So 3 minus 2 is greater than or equal to 1. Yeah? Does that make sense?
We'll try prove that out.
And you could even lose more points, right? But you lose at least 1 point like that, yeah? Okay, so there's a little bit of a subtlety here because the chain yeah, so I guess there's a little bit of a subtlety here because the chain that defines the level for the purple thing might not be the same as the chain that defines the level for the red thing, okay? But it doesn't actually matter because if they don't overlap at all, okay, then the purple one has to be smaller. So sorry, it has to be longer, and if it's longer, if it's longer, the points have still been lost. So if the chain is longer, then the change is less negative, right? So that's it's only helping you, okay? Wait, where are they? When is in the rain?
Echo noise. I think they forgot where to go.
I think it's just
No, it's fine. It's just Jikon's stomach rumbling. It's
No, it is raining. It is raining. I can hear it. I can't hear it. I hear it.
I called it.
Alright, we need to get a bit of a move on here.
Well, because it's thundering, it has to be raining, right? Like that's
Well,
the
we're
only
on the
logical.
14th floor.
Okay, let's continue.
Put that water on the floor. Yeah, but we can't hear it.
No, that's literally the only. That's the only liquid in the world that does not evaporate.
Oh yeah. It's a meme.
Okay, so that's just true, yeah? Okay.
Thing that doesn't evaporate.
Oh wait, no,
That's-
it's fine,
that's-
it's fine.
Sun would be there.
Yeah.
Little sun.
Oh,
Little sun.
Oh
It's
god.
mini sun.
Mini Chi, I'm kidding.
What?
I accidentally called you
Mini sun.
Mini
uh,
Mini Chi.
Mini
Mini
sun. It's raining.
Josh.
okay.
Josh.
So
Mini sun.
so we proved lemma 1 and 2, okay?
Mini sun. Yes.
Okay.
And then
Oh my god.
So we can prove proposition.
So look at proposition 1, okay? Okay, so proposition 1, let's prove that by induction, okay?
yeah.
So proposition 1, let's see. Proposition 1 says if you sum up all the points lost, yeah? Do you know this notation? Sum. So if you sum up all the points lost from the first points lost to the jth point lost, and you add that to the jth level, that's always greater than or equal to j minus 1. Okay? And this is for all j less than n minus 1 greater than 1. So proof. So let's do this by induction, okay? So what is it for like j equal, what is the low values of j? Let's have a look. J equals 1 and j equals 2. Let's just look at the low ones, okay? So j equals 1 is p1 plus l1 is greater than or equal to 0.
Well, that's definitely correct.
That's pointless, right?
That's definitely.
I think that's definitely.
P2, so J2 is P1 plus P2 plus L2 is greater than or equal to 1, yeah?
Yeah.
Is that also obviously true?
P2 plus L2 is bigger than greater than 1. And then
Yeah, so P1 is just 0, so that's this, we've already proved this before, right?
Yeah.
Okay,
Yeah, that was definitely.
so induction hypothesis, okay? So induction hypothesis, this is, you know how I was saying, assuming anytime it's true, prove it's true for the next one, right? So the induction hypothesis is just the assuming it's true, yeah? So assume it's true that the sum up to j, right? So I can use another letter. I can use the letter k, yeah?
So we already have K.
No, we don't.
Not really.
In my notation, I use K.
Plus lk is greater than or equal to k minus 1 for shush. So stop picking on the unimportant things and missing the important things.
Oh
Yeah?
no! Echo came first. And Jules with Echo. Okay. Whoa.
Whoa.
We must finish this question before they come.
Yeah, otherwise they're gonna steal it.
I did not say Stefan's name.
Back to Echo.
Yeah.
Okay, so for k is less than oi, shush. We're gonna eat dinner in like 15 minutes. Okay, we're almost there.
Okay.
So k is less than or equal to n minus 2. Okay.
Oh, I thought like I was getting.
So and then we're trying to prove. So this is the induction step. Okay. Prove the sum of k plus 1 pi plus LK is greater than or equal to
K copy
K plus 1 minus 1. Yeah?
to the K basically.
Okay, so now how do we prove this? Well, look at this. The sum of K plus 1 equals 1 Pi
Just the previous thing.
plus LK plus 1 is equal to the previous thing. So this is just adding all the p's up. So we can add all the p's up to the one before
This is plus P of K
plus p of K plus 1, right? Plus LK plus 1 minus LK, yeah? Plus LK, yeah? Okay, so the induction hypothesis says this thing here plus this thing here, right, is greater than or equal to K minus 1, right? Okay, and then we're plussing PK plus 1 minus plus, this is delta, this is our delta LK plus 1, right? And that's greater than or equal to 1, right? So this is greater than or equal to K, right?
Yay.
And that is K plus 1 minus 1, yeah?
That is it for the.
Wait, how do you know that P of K plus 1 is delta of K plus 1 square root?
Jordan.
Welcome!
Jordan.
Just in time for dinner.
As always.
Oh, with the Kirks.
We haven't.
How did you get the curves?
Guys, have you met Josh?
Josh, interrogate
Oh,
them.
that
No, it's
I'm that person. Oh, actually, that person.
no, it's the same as the other Josh. It just looks different.
person.
Yeah, he's got.
Josh, say your favorite phrase.
Yeah.
He's my quote.
No! Wait, you know there are children in the vicinity.
Yeah. His favorite phrase involves a word that starts with S and ends with X.
Okay, guys, we're almost done. Okay,
Six!
guys, we're almost done. Look at this.
Gravity falls reference, gravity falls reference.
All right. Okay, so now we have a theorem, yeah.
Wait, what did I miss?
Oh, you'll have to catch up in the recording. So we timed it so we finished this before you even get here. But they went over
Wait, we have the
time.
maps thing.
Well, I'll show you the recording.
We have
Oh,
the
listen.
maps.
So theorem.
Listen to
Sum. Oh, listen. So sum of n from I equals 1 to pi is greater than or equal to n minus 1. Yeah. Okay. Yeah, it's funny. The next thing we do with June and Echo together will be actually the same as this, but it'll look nothing like this. So it'll be kind of interesting.
The doors open.
Okay.
But the maps is recorded, right? So.
Yeah,
Oh, yeah.
this is recorded. We just listen to our dance.
Listen.
Or we can just play.
Listen to this.
Which one's streaming?
Look, so this is the theorem, yeah? Proof. Okay. So look at the results we've already proved, yeah? So we write sum of n I equals 1 pi is equal to the sum of n minus 1 I equals 1 pi plus pn, right?
Yeah.
Okay. Now by lemma, by proposition 1, yeah? See, proposition 1 works for all L, yeah? Wait. Proposition 1 works for all L, okay? Less than or equal to n minus 1. So let's put n equals 1, n minus 1 for L, yeah? Okay, so actually Echo can even follow this formally, even if she doesn't know what the letters stand for.
Wait, what's the question?
Don't worry about the question. I'll tell you the question. We're actually over time for the previous segment. So, okay. So remember this.
What?
So lemma 2 was Pn is greater than or equal to Ln minus 1 plus 1, right? Okay. So here Pn is greater than or equal to Ln minus 1 plus 1. Yeah? See this? Yeah? So this here is lemma 2. Okay. Actually, this might make sense if you have the whiteboard link and the recording, yeah? Yeah, but
Like a level 1, like earlier.
yeah.
Oh.
Okay, but this should be actually finished now, so it's just these guys were kind of
Did we prove it?
Yeah, but we're just
we're not
subbing
finished.
Subbing
We've
it
proved the
in.
proposition, not the theorem. Look.
Theorem.
Okay, and then this thing here, right? That's proposition 1, you see?
Yeah.
So by proposition
N
1,
So I'm assuming
this is greater than or equal to n minus 1 minus 1, right?
So then plus 1, it's n minus 1, so therefore.
Yeah, which is equal to n minus 1. Yeah?
Oh.
So we proved that the sum of all the points lost is at least n minus 1. So we can't ever get more points than that minus n minus 1, right?
We have questions about a plane.
Corollary.
A what? It's about circle. Quick, circle.
So you play League of Legends?
Yeah, so it's kind of a nice proof. I'm gonna read the solution as well from the official solutions, and that's another chance for Echo and June to join back in. So the max score is at most n minus 1, n minus 2, on 2. It'll be so different that you won't have missed anything.
Wait, let me just read the question.
I'm honestly confused.
Then read the question.
Settle down.
Oh, I see.
I finally have someone that has a bigger voice than me.
No.
It's not
We
me,
have to
guys.
scream in cadets. Oh really? Well, G1's stomach was rumbly and I couldn't stand it. His stomach was just rumbly.
He's not started.
No, his stomach was rumbly. You couldn't even hear the.
Alright, dinner break.
Did you go to
That's like
Roughly 6 to 6:45 ish.
My prediction is still alive.
When does it end? Today?
Yay!
Out of
Hey guys, did you know